Hello everyone, welcome to the fourth lecture of our Python programming series. In our previous lecture, we learned about arithmetic operators and expressions. We learned how Python performs calculations using operators like addition, subtraction, multiplication, and division. And we also learned about other operators such as floor division, modulus operator, as well as the exponentiation operator, right? And today we are going to learn about how to make choices in our programs. Sometimes we have to choose between two options, right? So we'll learn how we are going to do that. Instead of just performing calculations, we'll learn how Python can make decisions, right? We learn how comparison operators work, how logical operators work, and how conditional statements like if else, and if elif else works, right? Then these are our learning objectives of the day. By the end of this lecture, you should be able to understand comparison operators and their Boolean results, use logical operators to combine conditions, write simple if statements, implement branching with if else, handle multiple branches with if elif else. This elif is basically I'll explain it in a bit, but it's basically else if, right? In Python, we don't write else if, we write elif. If you are coming from any other programming language, you might get confused, but because in other languages such as in C we use else if, but in Python we write elif, right? And you should also be able to build small decision making programs using these tools by the end of this lecture. These concepts are used in almost every real world program, right? So let's do a quick revision before we begin. We learned about variables. What are variables? Variables store our data, right? And we learned about data types, the different ways that variables store data, such as integer, float, strings, and boolean. We also learned about type conversion, how to convert one data type into another data type. We learned about arithmetic operators, plus, minus, multiplication, division, modulus, to compute values using decision logic. We'll be able to use these here, right? And then we also learned about what expressions are. So yeah, what is decision making? Think about the decisions you make every day. For example, if it's raining, you carry an umbrella. If you are hungry, you eat food. If your phone battery is low, then you charge it. In every situation, you first check the condition, and then according to that condition, you make a decision. You decide what to do. Programming works the same way, right? A program checks a condition, and depending on whether it's true or false, it decides which code to execute. So let's see what's written here. Decision making lets programs choose actions based on conditions. For example, these are some more examples of decision making in daily life. Is the student eligible to vote? Because we can take this as if you are older than 18, right? Eligible to vote, then the condition will be must be older than 18. Then if not older than 18, can't vote. Older than 18, can vote, right? Did the student pass the exam? Is a number positive or negative? Right? Python evaluates conditions to true or false and executes code accordingly. So now we move on to our next topic, comparison operators. Comparison operators. Before Python can make a decision, it needs a way to compare values, right? Comparison operators help us compare two values. The result of every comparison is either true or false. Let's see what's written here. Comparison operators compare two values and return a boolean. Boolean is true or false, right? Only two things, true or false. Then we use them to form conditions that control the program flow. For example, if 10 is greater than 5, true, like it returns true because it's true, right? 10 is greater than 5. Then is 5 is equal to 5? Yes, true. Is 7 less than 3? No, false. 7 is greater than 3, right? So it will return false. Every comparison evaluates true or false. Remember that. Let's look at the type of comparison operators. Here it is, this is the equal to operator. I told you, right? A single equal to sign is the assignment operator. So if we want to compare two values, we can't use that. So in programming languages, we use two equal to signs for comparison, right? For example, 5 equal to 5. Okay? Don't make this mistake. Don't accidentally write only one equal to operator. Don't accidentally write only one equal to sign, right? And then this is the not equal to. This exclamation mark in front of the equal to sign, this shows not equal to. Okay? Not equal to 5 is not equal to 3. This will return true because 5 is indeed not equal to 3. Right? If this was 5 not equal to and instead of 3 here it was written 5, then it would have returned a false value because 5 is equal to 5, right? This is, you know this already, greater than operator, 10 is greater than 5, yes. Less than operator, 3 is less than 8, it will return true. Then there is greater than or equal to operator, right? Quite a lot of operators here, but this is also an important operator. Greater than or equal to, this will return true if the number is either greater than or equal to, right? For example, this is 5 is greater than equal to 5. So since 5 is equal to 5, one of these conditions is being met, it will return true. If this was 8 is greater than equal to 5, then also it will return true because one of these conditions is being met, right? 8 is greater than 5, although it's not equal to, right? So, but if we write 4 here instead of 5, then it will return false because 4 is neither greater than 5 nor equal to 5, right? The same way less than equal to works. 4 is less than equal to 8. It's not equal to 8, but it is less than 8, right? So this will return true as well. There are some examples of comparison operators. Let's try it on a terminal once, right? Let's see. 10 is greater than 5. Yeah, let's start with that. Print 10 greater than 5. So, what do you think the output will be? Excuse me. So, take a moment to think about the output of this. I'll run this. True. It returns boolean true because 10 is indeed greater than 5. Now let's try the other operators. Let's try 10 is less than 5. Is 10 less than 5? What do you think will happen when we run this? It returns false because obviously 10 is greater than 5. Then we try is 10 equal to 10? True. And as I was saying, if we write only equal to here, instead of the double equal to signs, we write only a single equal to sign. Let's see what will happen then. 10 equal to 10 instead of 10 equal to 10, right? We run this and it's giving us an error because expression cannot contain assignment, right? This is the assignment operator in programming. It won't work like this. Comparison won't work like this. We run it. Now we're getting true again, right? So that's just a thing I wanted to tell you. And then let's try, is 28 less than equal to 30? True, because 28 is less than equal to, it's not equal to 30, it's less than 30, right? One of the conditions is being satisfied. And if we try 30 here, then also it will return true because 30 is equal to 30, right? Even though it's not less than. The same way, can look at, yeah, but wait. If we try 31 here, right? Let's also do this since we're doing everything else anyways. If we try 31, it's less than equal to 30 and try to run it, it returns false because 31 is neither less than or neither equal to, because 31 is neither less than nor equal to 30, right? So next let's try greater than equal to. Is 47 greater than equal to what? 30? Okay. True, because 47 is indeed greater than equal to 30. Let's see, we put 47 here and we run it. It's still true, right? But if we put here 60, then it will return a false. Then it will return false because obviously 60 is greater than 47. That's that. What else was there? Not equal to. Let's also try not equal to. Print 62 not equal to. Let's put 62 for now, right? If we run it, then we get a false because 62 is equal to 62, right? If we put here something else, 60, and we run it, then we get true because 62 is not equal to 60. And the condition evaluates to true, right? Alright, let's move on to logical operators now. Sometimes checking just one condition is not enough, right? If a university says a student can enter the examination hall only if they have their ID card and they have paid the examination fee, now we have two conditions here, right? Only checking one condition won't work. We have to check both conditions. So logical operators help us combine multiple conditions. Okay, this is the logical AND operator, the logical OR operator, the logical OR operator, and logical NOT operator. The AND operator returns true if both conditions are true. If, for example, in our previous example, if the student has the examination hall ticket or their ID card and they have paid their examination fee, then only they can enter. If both conditions are true, then they can enter. If even one condition is false, they won't be able to enter the examination hall, right? That's how it's work. Or true if at least one condition is true, right? In a previous example, it would fit something like the student can enter if they have their ID card or if they have paid their or if they had paid their examination fees, right? So it means that if they can have both, they could have their ID card as well as have paid their examination fee. But even if one of these is not true, if they forget their ID card, they can still enter if they have paid the examination fee. And if they haven't paid the examination fee, then they can still enter if they have their ID card, right? And then the not inverts a boolean value, right? Just like we had not equal to in our comparison operators, right? We had this not equal to. The same way we have a logical not as well, which inverts the boolean value. If the actual answer is true, it will return false, and if the answer is false, then it will return true, right? Let's get it. So this design flowchart is basically to visualize the conditions, right? First we evaluate the condition. If it's true, we execute it. If false, skip, alternate path. We look at this. You will be able to understand this better after I explain if condition to you, right? This basically shows the core idea of a condition, right? You can also look at it here. Start, check condition. If condition is true, this condition is false, this will be understood better in the if else section of this video. Okay, so let's look at the and or and not operators, right? First of all, the and operator. As I told you, the and operator returns true only when both the conditions are true. Think of it like two locks on a door, right? Both locks must be unlocked before the door opens. You know what? Let's try it once. Let's code this thing. We'll delete this and open a new terminal. So yeah, we can do print 5 greater than 3 and this is our AND operator, logical AND, 8 greater than 2, right? 5 is greater than 3, yes. 8 is greater than 2, yes. We get true, okay? If we make one of the conditions false, let's see, 8 is greater than 20, and then we run it, what do you think we'll get? False. Because although one condition is true, but the other condition is false, so the overall answer will be false. Obviously, if we make both of them false and we run it, it will still return false, right? So the logical AND operator returns true only when both conditions are true. And now it's giving us true again because 5 is greater than 3 and 30 is greater than 20. Then there's the OR operator. You could just think of it as being less strict, right? Less strict. Only one condition needs to be true. For example, if you have holidays on Saturday and Sunday, then you can say if today is Saturday or Sunday, then I don't have any classes. If either of the condition is true, then the entire expression becomes true, right? We'll just try it once. And if if 14 is equal to 14, or if 34, let's first make both the conditions true, right? 34 is greater than 22 and 14 is equal to 14. Remember, double equal to signs, right? And if we run this, what do you think we'll get? That's right, we'll get true. Because both conditions are true, we'll get true. Now if we make one condition false, we write something else here. If we write 14 is equal to 15 or 34 is greater than 22, what will our answer be? Let's run this. And we still get true. If we do that here, we're going to get false. If we make even one condition false, as we saw, if we make it 19 and we run that, the AND operator makes this whole expression false. But OR operator, even if this thing is false, even if this is false, but this is true, this whole thing evaluates to true. Here, if one condition is false, even if the other is true, it will still return false. That's that. If we make both conditions false this time, let's put this back. Yeah, if we make both of them false, and we run it, what do you think our answer will be? Yes, it will be false because both are false now, right? So that was for our OR operator. Now there is the NOT operator, which will return false if the actual expression is true and return true if it's false. We can just try it here. If we write print, this one is a little difficult to showcase without the other elements of our program, but let's write not true, right? So first of all, is this true correct? We learned about it in our previous lecture. Is this correct? Will this work? No, it throws us an error. Why is it? We have written true, the spellings are correct. Why is it returning an error? Because we learned that Python is a case-sensitive language. True with a capital T and true with a small t mean two different things. So we'll just put this in uppercase. Now this is valid, right? True with a lowercase t is not defined in Python. So if we try this and run it, it returns false. Not true. The opposite of true, false. Okay? That's it for our NOT operator. We can look at the examples given here as well. For AND operator, if 5 is greater than 3 and 8 is greater than 2, true. If 5 is greater than 8 and 10 is greater than 2, then it will give false because 5 is not greater than 8. One of the conditions became false, so the whole expression became false. Then there's the OR operator. If 5 is greater than 8 or if 10 is greater than true, then it will return true because even if one of the conditions is false, one is true, right? So it will return true. Then if both conditions are false, if 4 is greater than 8, it isn't. Or if 6 is greater than 9, it isn't. So if both the conditions are false, then it will return false. Then we have a NOT operator. Not 5 greater than 3, false, reverses the Boolean result, right? Let me show it to you like this also. I showed it to you with true, but let's try this as well. Print not 14 equal to 14. Easiest example, right? So print not 14 is equal to 14. Is 14 equal to 14? Yes. So technically this should return true. But since we put the not operator here, what do you think our answer should be? Let's run it. It's returning false. The opposite. If we make this condition inside this not false, 14 equal to 18, which is technically false, but since we put the not operator here, if we run this, we get true, the opposite, right? The answer is reversed. We've already tried this, right? The not operator in Python reverses the Boolean value. Use it when you want the opposite of a condition. Now we move on to a very important concept, which is the if statement. So what is an if statement? Hello. Yeah. So what is an if statement? So far our programs have simply followed instructions one after another. No matter what input we give, they always executed every line of code, right? Whatever we told it to do, it did. But in real life, we need to make decisions all the time. For example, as I think I gave this example earlier as well. If it's raining, we carry an umbrella. If we are hungry, we eat food. And if we finish our homework, we can watch a movie, right? Notice something common in all these examples. First, we check a condition. If it's raining, then I'll carry an umbrella. If it's not raining, then I don't need the umbrella. If I am hungry, then I'll eat my food. If I am not hungry, then I won't eat it now. If I finish my homework, if you finish your homework, then you can watch the movie. Otherwise, you can't. You have to finish your homework first. So we've checked the condition first, and then based on whether the condition is true or if it's false, we decide which action to take. Python works the same way. The if statement allows a program to make decisions. It checks whether a condition is true. If the condition is true, Python executes the code inside the if block. False, Python simply skips that block, right? And it moves on. So this is the syntax for it. The syntax is basically so this is the syntax for the if statements. You might be wondering what the hell is syntax. Syntax is basically sort of like the grammar for programming, right? It is a set of rules that define the structure of the code, how it's written, and the syntax is different for every programming language really. And unlike human language where we can skip some things, like if I'm talking to you, I said right? I didn't say I am talking to you. I said I'm talking to you. I shortened it, I skipped some words, right? If we if I ask you, do you want an ice cream? I can just look at you and say ice cream, and you'll understand it because this is the human language, right? But if we are writing a code, the computer does not understand nuance and whatever. It is very strict. If we skip even one thing, it will throw an error, right? It will throw a syntax error. So the syntax is very important in programming. So this is the syntax for the if statement in Python. If condition colon enter, and we write our statement here, right? If is basically the keyword that starts the decision. Then condition, we write our condition here. This is something that Python can evaluate, right? Evaluate whether if it's true or if it's false, just like we were doing here, right? These are conditions. Okay, so you can put one of these conditions here, and then the colon tells us that the block of code is about to begin, and we write our statement here. It's basically if the condition is true, then execute this statement, the block of code that we write here, right? So a simple example, let's do it on our code editor. We'll just remove this, and then we can just kill this terminal, new terminal. Yes, so let's look at our example. Let's take it as if. What example should we take? Let's check if a person is eligible to vote, right? Where the age for voting is 18 and above, right? We want to check if the user can vote. We take a variable age. Let's take this input from the user. Do you remember how we take an input from the user? What do we use to take an input from the user? Yes, it's the input function. Input, please enter your age. So, are we forgetting something important? We're taking an integer for an input. Are we forgetting something here? Is this correct? Yes, we have to write int here because input function returns a string value, but we need an integer here to check the condition, right? So now we start our if block. We write if, then we have to write the condition. What is the condition for being eligible to vote? Being 18 years or above, right? So we just write age. We'll write this variable here, the age that we took, greater than or equal to 18. If age is greater than or equal to 18, then we put a colon here. This shows that we are about to begin our statement. Enter. Then we type our statement here. Print you are eligible to vote. let's write congratulations here. Congratulations, you are eligible to vote, right? So look at it. If the age is greater than 18, the colon that indicates the start of the block, enter. This is the statement. Print. Congratulations, you are eligible to vote. Shall we run this now? Please enter your age. Let's enter 42. Press enter. Congratulations, you are eligible to vote. Okay. Then to check it, let's run this again. Let's enter 18. Will this still work? Let's see. Let's run it. Wait. Okay, it's working now. I don't know. Maybe I tried something else. And it's still working. Please enter your age, 18. Congratulations, you are eligible to vote. Right? So if we run it again and we type something else, if we type an age less than 18, let's see what happens then. Otherwise it will just be like, it's just printing, right? It's printing everything, whatever the condition is. So enter your age, we'll write 16 and we run it. So now let's try to enter an age less than 18. Otherwise it will just be like it's printing every time, and then what would be the use of the condition, right? If it's printing every time. Let's enter the age as 16 this time and we run it, and as you can see it didn't print anything. We entered our age 16, we didn't get any output from this. Why is that? Because we have a condition age must be greater than 18, right? Let's move on. We just did this example. Here they have already defined the age as 20. We just took the input from the user, right? You can look at it. Next. Now we have the if-else statement. In the previous example, when the condition was false, nothing happened, right? When we wrote 16 and we ran it, nothing happened, right? But what if we want the program to do something else when the condition is false? That's where the else statement comes in. Think of it like this: if it rains, carry an umbrella. Otherwise, carry sunglasses because it will be sunny. So yeah, or if you score less than 30 marks, you pass. Otherwise, you fail. The else block gives Python another set of instructions to execute when the if condition is false, right? So this is the syntax for it. If condition, colon, the statement of the if condition, we just did this, and then after coming out from the statement blocks, we write else, colon, no condition here, we don't write any condition with else, we just write else colon, and then we press enter, statement, right? And this will basically go, if our condition is true, then it will print this statement and it will ignore this else box, right? It will ignore this thing and the code will stop. But if the condition is false, then it will ignore this thing, because obviously when the condition was false, nothing printed, and it will move on to else and print whatever is in the else block, right? Let's solve an example here. Again, we'll practice taking input from the user, right? We'll make a variable, let's name it marks. We'll take an input. Since we are taking an integer input, we need to convert it into int input. Please enter your marks, colon, and then let's write our if else. If marks are greater than equal to, let's just take it as 30, colon. Without the colon, it won't be the if statement, right? If we just enter and we write, let's try it like this also. Before moving on to if else, I'll show it to you. Without the colon, it won't work. We print let's just go XYZ for now. See, syntax error, it's giving a syntax error because we didn't put a colon here. What if we put a colon here and write the print here? Now what? It still won't work. Why won't it work? Because you see, if you have learned any other programming language before, maybe C or C++ or any programming language, you would know that usually when we type the if else blocks, we put brackets, right, to indicate that this is inside the if block. But here in Python, indentation is everything, right? Indentation shows that this print is inside this if block. If we put this outside if we don't indent it and if we put it right here, right below it, then it is throwing a syntax error. Let's press tab here, right? Now it is inside the if block. So you also have to be particular about this, right? Indentation is important in Python because it doesn't use all of those curly braces and all of that, right? So will it work now? It doesn't throw an error. Let's try it. Marks are greater than 30. Let's write 40. And it printed XYZ. It worked, right? Indentation is very important in Python. Now then, let's move on to our if else blocks now that we are clear about that. If marks are greater than 30, print congratulations, you have passed the exam. Now, here's the thing. If we write our else here, right, this is again incorrect indentation. because now this else, instead of being its own block, is nested inside this. It's inside this if block, right? And that will also throw an error. It won't work the way we want it to work. I'll show it to you once. What was the syntax for else? Else colon, oh, it fixed itself. I want to make this mistake. The editor is like, no, I won't let you. And if we put this here and we write our statement here, print, doesn't matter right now, so we run it, and it's giving us invalid syntax because we didn't take care of the indentation. We have to put this right below, sorry, we have to put the if block, right? We have to put the else block right below the if block, right? We can't, if we put it like this below this statement, then it's become a part of the if block. Okay, so we'll remove this. If we're coming from here, press enter. We have to press a backspace here because we can't type it here. We go here, else colon, inside the else block, we can't put it here, inside it, right? Print you have failed the exam. Better luck next time. Let's open a new terminal. And we'll run it. Please enter your marks. First, let's enter passing marks. Let's write 31. Barely passed. Let's enter. Congratulations, you have passed the exam. See, it skipped this else blocks. It didn't print you have failed the exam, better luck next time. It just checked the marks were greater than 30, so it printed this thing and skipped this if else blocks entirely, right? Now if we run it again, please enter your marks. This time let's enter 13. You have failed the exam, better luck next time. This time it checked the condition and it didn't print this thing. It moved on to the else block. It was skipping the else block earlier, right? So it moved on to the else block and printed you have failed the exam, better luck next time. So that is basically how the if else blocks work. Since this is equal to, let's also try equal to. Will it print this if it is equal to 30, or if it's, will it print this if the marks are 30, or will it print this? Let's go, we run this. Enter your marks 30. So let's run this. Enter your marks 30. Press enter. Congratulations, you have passed the exam, right? So it's working. Let's move on now to if, elif, else. If there are multiple conditions, then we can use the elif block, right? Elif is basically else if, right? If, else if, else. Okay? So far we have only checked one condition, but what if there are multiple possibilities, right? For example, if we want to write a program to assign the grades to students according to their marks, right? We'll write something like, if the marks are 90 or above, the student gets an A grade. If they are between 70 and 80, then the student will get a B grade, otherwise they will get a C grade. Or we can only write one if condition, but we can write multiple else if conditions, right? We can write, after one else if of if the marks are between 70 and 80, we can write another else if the marks are between 60 and 70, and if the marks are between 50 and 60, like this, right? So it's used to check additional conditions. When the first if is false, the first true branch runs and the rest are skipped. Okay, this is the syntax. If condition statement. Elif, don't accidentally write else if, right? Because the meaning is else if. Sometimes we get confused and write else if, but it's elif. Okay, elif. Condition statement, and then at the end we write else statement. So Python basically checks the conditions one by one from the top to the bottom, and like we said, if one condition is true, Python executes the block. Otherwise, it will execute it and it will stop checking the rest of the conditions, right? Let's solve an example here. Open a new file. Remember, when you are making files for Python code, then you have to write .py extension, right? We'll just go ahead and we are going to make a program to assign the grades to the students, right? First, let's write a shorter one. We'll just, like in the previous program, we'll ask for the marks from the user. Int input, you know that by now. Please enter your marks. And then we write if, we don't have to use it. If marks are greater than or equal to 90, print your grade is A. Now we write elif condition, marks are greater than 75. Let's write it. We won't make a complicated program yet, but in the future we'll write a program to assign all of the grades, A, B, C, D, E, fail, everything, right? For now, let's just go this and we write print your grade is B, else print your grade is C. Let's run it, shall we? Let's write 82. Okay, wait. Let's start from the top. Let's first write 98. Okay. Enter. Your grade is A. Okay. Let's do 82 this time. Enter. Your grade is B, right? Since this was greater than 90, 98, we got a grade A, and the rest was skipped. Now we entered marks 82. 82 is less than 90, so this first statement was false. Then it moved to this thing. 82 is greater than 75, so we got our grade B. And we try it again, and we enter 64. Then we'll get our grade is C, because 64, is it greater than 90? No, false. Greater than 75? False. So in the end it fell into the else statement, and we got our grades as C, right? So Python executes only one block of code here, right? Indentation. As I told you earlier, indentation is very important in Python. It's a very important rule in Python. Oh dear. Unlike many programming languages, Python uses indentation to identify blocks of code instead of the brackets, as I told you. It simply means leaving some space before a line of code. For example, if we look at this thing, Python starts a little to the right, right? We tried putting it here and it didn't work. This is indentation. This tells Python that this thing belongs inside our if block, right? If we remove it, it doesn't work, therefore. Because Python, how would Python know that this print statement is part of the if condition? It doesn't know. It only knows through indentation. Okay? So whenever you write an if condition or else, elif, right? Always remember to indent the code inside the block. Let's now move on to our practice questions. First, you should try to practice it by yourself. Try to write this code. Try to execute it. If it doesn't work, then you can come back to the video and check it. If it works, then obviously nice. If it doesn't work, then you can always come back to the video and check it, right? Let's just delete this thing. We don't need it. So let's start with our first question. What was that? Check if a person is eligible to vote. The age for voting is 18 and above. Okay. Go ahead. We already did this, but without the else statement, right? First we get the age from the user. We know how to do that, right? Input. Please enter your age. If age is greater than or equal to 18, print you are eligible to vote. What should the program do if you are not eligible to vote? You can just print you must be 18 and above to vote. Okay, we can run this. Let's write 19. You are eligible to vote. Let's run this again and write 16. Okay, let's run it and write 16 this time. You must be 18 and above to vote. Okay, so that was easy. We already did a similar thing just now. Let's look at our next question. Determine if a number is positive, negative, or zero. All right. Let's write. Let's first take in a number, right? Number from the user. Number is equal to, since we're taking a number as an input, we write int input, enter a number. If our question was to check if the number is positive or negative, right? So we can just write if number is greater than 0, print number is, let's write given number. Given number is positive. Else print given number is negative. Let's run it once. Let's start with the positive number 10. Given number is positive. Okay. Run it again. Let's write 0. 0 is neither positive or negative, but let's try what happens when we write that. You run it. Okay, so let's enter 0 this time, right? 0 is neither positive nor negative. So let's see what happens when we do that. Given number is negative. Why is it doing that? Because we didn't think of the edge cases, right? 0 is neither positive nor negative, right? So this is technically wrong, right? We'll fix this in a bit. Can just first let's finish writing this. Enter a number. This time we'll enter a negative number, -5. Run it. Let's open a new terminal and let's run it, and this time we'll enter an actual negative number, -5, and if we press enter, yes, given number is negative. This is correct. Now to account for the 0 here, which is neither positive nor negative, what can we do? Now we want to write two conditions. Yes, we can use elif here. Elif colon yes, so we can use elif here. Go out of the if block. Elif our condition this time is number should be equal to 0 because we are accounting for the case where it's 0. 0 is not negative, right? We got number. What is the equal to operator here? Is it this? No, it's this. Number equal to 0. Then print number is neither positive nor negative. Okay. So now if we run this thing, enter a number, let's enter 0 this time, and we got number is neither positive nor negative, right? So this is a program to check whether number is positive or negative. Okay. Let's change the name of this to, you can rename it like this, right? Therefore, positive or negative. Yeah. Let's open a new file. What is our next question? Check whether student failed or passed. We already did this. You can do this. I'll show it to you anyways, but yes. We'll take in the marks. It might feel repetitive, but it sticks to your head if you repeat it again and again, right? Input, enter your marks. If, what was the criteria for passing here? Pass mark here is 33 in the question. So if marks are greater than or equal to 33, print you have passed. Go out of the if block, else colon, print you have failed. Enter your marks. If we write 33, you have passed. If you write 40, you have passed again. But if we write 19, you have failed. Okay, so it's working properly. And that's it for our third question. In a new terminal. What is our next question? Find the greater of two numbers and print it. Okay, so for this one, let's go here. To find the greater of two numbers, we need two numbers. Let's take them from the user again. Int input, enter first number, num2, int input, enter second number. Now, how would we know if a number is greater? If we have two numbers, how are we supposed to know which of the number is greater? Yes, we can put a condition here. If num1 is greater than num2, this is not a perfect example because we are only doing beginner examples, right? Because what if the second number is greater or whatever. We are using this condition if num1 is greater than num2. Obviously, if the numbers are equal, then we can try something else, but right now our condition is to check whether, so yeah, we're using this condition, and for inside it we'll write print if num1 is greater, then we'll write first number is greater, else if this condition is false, then that means that num2 is greater, so we'll write print second number is greater, right? Let's run it. The first number will take a small number, 5, 8. Here we took the second number greater. Second number is greater. It's working properly. We'll run this again. Let's take the first number greater this time. Let's take the first number as 8 and the second number as 5. And first number is greater, right? So what if we take both numbers as equal here? What will happen then? First number 8, second number 8 as well. Here it's giving second number is greater, right? So these are the edge cases and all. We'll learn more about how to handle this type of situation in the future, right? It will become a little complicated here if I try to show it to you. So for now, we'll only do this, okay? Let's look at our next question. Check if a number is even or odd using modulo. Yes, this is what we were talking about in our previous lecture, how we can use modulo to check if a number is even or odd. Now that we know the if statements, we can finally do this. Read so yeah, we'll take the number as input from user as we have been doing. Enter a number. Then we go if. What will be the condition? Think about it. We learned about the modulo operator in our last lecture, right? So when will it be even and when will it be odd? What is the condition for a number to be even? It should be divisible by 2, right? So if a number is divisible by 2, then its remainder should be 0, right? And which operator gives us the remainder? The modulo operator. It gives us the remainder after division. So we write if number modulus 2, right? If our remainder, modulus gives us the remainder after division, right? Is equal to 0. So if number modulus 2 is equal to 0, because if a number is divisible by 2, then the remainder will obviously be 0, right? Otherwise it won't be 0. So if it is equal to 0, here we are using two operators at once, we can do this, right? So we go print number is even, right? Else if the remainder is not 0, then that means that the number is not fully divisible by 2, hence it's not even. So we'll write print number is odd. Oh, okay. And if we run this, let's first take an even number. 14. 14 is an even number, we know that. Enter. Number is even. We run this again. Let's enter an odd number. 5. Number is odd. Our program is working properly, right? So yeah, as for our last example, for our last question, print letter grades using if, elif and else for ranges. Okay. So we'll just delete this thing. So first of all, obviously we need the marks if we want to calculate the grade. Int input, please enter your marks. Then first we'll write if marks. We did a similar program, right? But this time we'll print all the grades. That was shorter. This time we'll print grade A, B, C, D, E, and what happens if the grade is lower than E, right? So let's start with this. If marks are greater than 90, print your grade is A. Elif, because we are checking multiple conditions here, right? This is basically our practice to check our multiple conditions. So elif, our second condition, marks are greater than equal to 80, print your grade is B. Then we'll write elif marks greater than equal to 70. Print your grade is C. Elif again. See, we can use multiple elifs. We can only use one if. You can't write if again and again. But elif you can write as many elifs as you want. I could even write 20 elifs if I wanted, right? I can just keep writing these elifs. But if you can only write once, and else you can only write once. Elif as many as you want, as many as necessary. Marks greater than equal to 60. Print your grade is D. Elif again, marks greater than equal to 50. Print your grade is E. And now finally we'll write else. If all of these don't work, if all of these are false, that means if your marks are less than 50, then we print you have failed. Okay, so we run this, enter your marks. Let's enter 92, your grade is A. Enter 85, your grade is B. Let's enter 75, your grade is C. If we enter 62, then our grade is D, right? If we enter, let's enter 55, then our grade is E. And if it's less than 50, if we type it as 40, then you have failed, right? So this, we made a simple program to assign the grade to the mark of the student, right? It's easy, but it's progress, right? We couldn't write all of this earlier, and we used so many concepts here. Alright, so that's it for our lecture today. Let's quickly recap what we learned today. We learned how Python makes decisions using conditional statements. We studied comparison operators and logical operators which help us create conditions. Then we learned about the types of decision making statements: if, else if. Then we learned about the types of decision making statements: if else, if elif else, right? We also learned about indentation, which is one of the most important syntax rules in Python. With these conditions, your programs can now make decisions instead of simply executing every line of code that we give it, right? In the next lecture, we'll move on to loops, where we'll learn how to repeat tasks automatically instead of writing the same code again and again over and over, right? So yes, thank you for watching this lecture.